Turn it on. Okay, so it's on the pH mode right now. I'm going to basically stick it in the water first and just see what it measures. Looks like the water is measuring at 6.5, 6.6. Let's see if it changes anymore. Oh, it's still changing a little bit. Not sure how long it takes to stabilize. Hopefully it doesn't keep going up too far, right? Okay, looks like that's pretty stable at 7.1. So we can record that in our table. Seven 7.1 before the HCl. Wash the electrode in between each measurement. Good squirt there. Wipe it dry again. Now we're going to measure the pH of the phosphate buffer. Let's see what this is. The container says it's supposed to be pH 6. We'll see if it goes down that far. This is telling us that it takes a little bit of time for the pH to stabilize. Let's see. All right, looks like it's 6.6. Right. Wash the electrode again. The water is known to not be a buffer. The phosphate buffer is a known buffer. So what we're going to do now is we are going to add a little bit of hydrochloric acid, which has a very low pH. So I am using a special pipette tip that has a barrier in it. This is to prevent damage to the micropipetter. And I am going to measure 100 microliters of 0.1 molar HCl. And I'm going to put that into each one of these tubes. So I'm going to basically come down here. I'm just going to squirt it in. And I go squirt it into the next one as well. Close the caps, spill the hydrochloric acid. Now I'm going to do a little bit of mixing, just make sure that the hydrochloric acid is evenly dispersed throughout the two liquids. And I am ready to measure the pH of the water. All right, let's stick the electrode into the water, and you see that the pH is going down. We'll see where it stabilizes at. Do a little bit of wiggling here, just in case that speeds up the process of getting a stable number. It looks like it's holding steady at 2.9. Wash the electrode again. I can insert it into the phosphate buffer that has the hydrochloric acid in it. Wiggle that a little bit. pH was 6.6 without the hydrochloric acid. We'll see where it stabilizes at here. Looks like it's steady at 6.5. Okay. I think it was 3.5. And we see that there's a big change in pH when hydrochloric acid was added to the water, but a very minimal change when hydrochloric acid was added to phosphate buffer. This indicates that phosphate buffer is acting as a buffer, stabilizing the pH, whereas water is not a buffer. We're now ready to test our other solutions. Here, maybe we don't know if they're buffers or not to begin with, so we can go ahead and take some more measurements. Wash the electrode again. And we're going to want to take the pH of these other solutions. Here we have the sodium chloride solution. Stick the electrode in. Okay, it's right around 7.2. See if it stabilizes. 7.2, 7.3. Oh, went up to 7.4. I think we'll call that 7.3. Do the milk next. What we're doing is we're taking the pH before we add hydrochloric acid now. Moving just a little bit. All right, 6.6 for the milk. One more solution to measure, which is the Alka-Seltzer. .4 looks like. Okay, 6.4. pH of the Alka-Seltzer solution. Wiggle it around a little bit. Wait till it stabilizes. Looks like it's at 6.4. All right, we'll record that. 6.4. Okay. All right, so I'm just going to go screw it in there. Close the lid. We'll mix these up a little bit. Last solution now, the Alka-Seltzer. All right, we're ready to measure the pH of the sodium chloride with the added hydrochloric acid. So place that into the tube. All right, you can see the pH went way down to 2.5. All right, 2.5 for the sodium chloride. And we'll go to the milk solution. Dip the electrode in there. All right, looks like 6.3. pH meter a good rinse. Ready to measure the pH of the Alka-Seltzer solution. Move it around a little bit. Looks like it's pretty stable at 6.4. So on this table we have an extra row because we might have students test a different antacid or a different solution in the same way that we did the others. We're now going to go to the last column where we want to indicate whether the solution is a effective buffer or not. And basically what we're doing is we're taking a look at how the pH changed after adding the hydrochloric acid. The milk looked like the pH changed a little bit, went down a few tenths of a point, but didn't go down very much. So we're going to say that milk is a good buffer. The sodium chloride went from 7.3 down to 2.5. The pH changed a lot, so sodium chloride is not a good buffer. But with Alka-Seltzer, it stayed steady at 6.4. So Alka-Seltzer is also an effective buffer. So yes here.